Okay, so a couple of you had come to me saying you were a little confused about reference angles versus coterminal angles, and some people were absent and they were kind of getting caught up with the lesson. So I did want to make a little video about coterminal angles and reference angles. Let's just take 120 degrees for a second. Here's my Ferris wheel. So 120 degrees would be the Ferris wheel, the car would be in this position, okay? If I want to get my height and my co-height, here's my triangle that I can draw. Here's my co-height, here's my height, okay? My angle, the angle of 120 degrees, is this blue angle that I'm going to draw here. This would be the angle of 120 degrees. But that's not the angle that I'm going to actually use to figure out my height and my co-height. What I'm going to do is I'm going to get this angle right here, which is 60 degrees. That's called the reference angle. All right? This angle of 60 degrees is called the reference angle. That's the angle that you would ultimately use to create your triangle. And so what I was saying in class, because some kids were kind of defining it this way, was that if I look at a first quadrant situation, so if I take the 120 away for just a second, if I look at my first quadrant situation, if I had a 60-degree angle in the first quadrant, it would look like this. And the situation in the other green triangle, there's a symmetry here. And so that 60 degrees is going to reference back to this 60 degrees. And that's why it's called the reference angle. Okay? So what I want to do is actually, so that's what a reference angle is. Basically, it's the angle that you're referencing to draw your triangle so that you could actually solve. Coterminal angles are a little different. Coterminal literally means that the two angles end up in the same place. So for example, again, if I had my 120-degree angle, okay, so if I had my 120-degree angle, I hopefully noticed in the chart that the 120-degree angle, if you remember, if we go back to our chart here, whoops, where is it? Here's our chart. The 120-degree angle, I ended up with the height of the passenger car being 25 radical 3 and the co-height being negative 25. If you go to 480, you also end up at 25 radical 3 being the height and negative 25 being the co-height, because at a 480-degree rotation, you're in the exact same spot. So follow me on this. So if I wanted to rotate 480 degrees, I would be going 90, 180, 270, 360, 450, and then another 30 to get to 480. You end up in the same place as if you were actually only rotating 120. So what we say is that 480 degrees is coterminal with 120 degrees. They're the same thing. So now, if I look at the relationship between 480 and 120, they are 360 degrees apart, which makes sense. Because obviously, if I'm getting to 480 degrees, what that means is I went around 360 and then another 120. That 360 is the full circle around. So I start back at 0, essentially, and go another 120, and I'm at 480, which gives me the same place as 120. Now, you can do this backwards as well. So let's say I want to get to this point, but I want to use a negative angle. Well, I can go 90, 180, plus another 60 to get there. So that would be negative 240 degrees. And if I look at 120 and negative 240, and I subtract them, I'll get 360. The difference between them is 360 degrees. So negative 240 is also coterminal with 120 and coterminal with 480. And you could keep doing this. You could keep adding and subtracting multiples of 360 to go around and around and around and around and end up at the same spot. It's sort of like if you watch Wheel of Fortune. It doesn't matter how many times the wheel goes around. If it lands on bankrupt, you're going to be bankrupt. So that's the idea of coterminal angles. The coterminal angles end up in the same spot. So I'm going to walk you through a couple of examples of these that are in the homework. So let's say I had a 150-degree angle. So first things first, I want to sketch that. So I almost think of it like this. Draw your Ferris wheel, okay, and draw a 150-degree angle, which would be 90 and then another 60 gets you to 150. That's a 150-degree angle, and that's what's meant by sketching the angle in standard position. Then, if you draw your triangle that we've been drawing to figure out the height and the co-height, actually, I'm just going to make this a little bigger. If you draw your triangle that we've been drawing to get the height and the co-height, so here's your 150-degree angle. If you draw your triangle that we've been getting to get the co-height and the height, okay, now notice this is my 150-degree angle, but my reference angle is right here. That's the situation that's symmetric with my first quadrant situation. So the reference angle here, if I think about what this is, if I were to go all the way across the two quadrants, that yellow angle would be 180 degrees. But I have, the green part gives me 150, so the blue leftover part is 30 degrees. So the reference angle here is just 30 degrees. And what I mean by symmetry is that this is the symmetric triangle to the triangle in the first quadrant, where 30 degrees is just the regular angle. That's the symmetry that exists that a lot of people were referring to today. Okay, so that's my reference angle, and that's where it's located. So we determine the location and the measure of the reference angle. Now I want to determine the measures of three other angles that are coterminal. Well, I'm at 150 degrees. So if I'm at 150 degrees and I add another 360, that's just going to go around another circle. So 150 plus 360 gives me 510, and 510 is coterminal with 150. Now, I don't have to go forwards. I can go backwards to get to my angle. So I can go in the negative direction. So I'll take my red marker and go negative. I can go negative 90, negative 180, and then another 30, as you could see from that reference angle that we calculated. I can get to negative 210. So now I know I have 510, and I have negative 210. So I need a third one. Well, I could do another negative 360 around. So I could do negative 210 minus 360, which is, what is that? Negative 570. So my coterminal angles, I can kind of list them here. 510, negative 210, negative 570. Those are three, and you can keep getting more. There are going to be infinitely many of these. And I almost want you to start thinking about the graph of like our sine and cosine functions. That's going to be related to all this. So I'm trying to set the stage while teaching some of these concepts. All right, I want to do a few more of these with you on this video. So here's number 6. So negative 120. Okay. So negative 120, where am I? Well, I want to draw my Ferris wheel. Negative 120. I'm going negative 90 and then another 30. So here's my Ferris wheel. This would be an angle of negative 120. And my reference angle, again, I want to draw a picture that's symmetric. So if I'm thinking about my first quadrant situation, right, the angle would be here. This would be the reference angle. It's the vertical angle. That's the symmetry. Another way to get it is you're drawing your co-height and your height, okay? And this guy here is the reference angle. So if I went 120 degrees backwards, okay, if I were to just go all the way through the fourth and third quadrants, that would be 180. 180 minus the black 120 gives you the 60. The reference angle is 60 degrees, therefore. Now, here's where people get confused, and I know this is perhaps a bit arbitrary. The reference angle is not this angle here. It's not the angle that I just X'd off. It's not the 30, it's the 60. It's because when we start rotating, we rotate from 0 degrees, which is where I just put the blue, and that's going to give me the symmetric picture that I have here. So it's always, the reference angle is always connected to the x-axis. Because if you think about the symmetric picture in the first quadrant, that's where the symmetry exists. I know someone could say, well, this angle is congruent to this angle as well, but that's not the angle that we're rotating by. So if you start at the origin and rotate up, that's a 60-degree rotation here, not here. So the angle is always connected to the x-axis because of how we define rotations in the plane. Okay, that's my reference angle. Now I want to be coterminal with 120. Sorry, negative 120. So let me erase some of this. It gets in the way. So I want to be coterminal with negative 120. Well, I could go around clockwise, counterclockwise. Positive 90, positive 180, and then another positive 60. So another coterminal angle here could be 240. Another way to get the 240 is just to take negative 120 and add 360 to it. 360 gives you a full rotation. So if you're at negative 120, and rotate 360 back, you're going to rotate a full circle, you're going to end up at the same spot. And that is 240 degrees. Okay? So check. You could keep adding 360 if you want to, if that's how you want to generate coterminal angles. So I have 0, 4 to 6 is 0, and we get 800 degrees. 600 degrees. So I get 600 degrees. You can do it that way. And you can continue to build coterminal angles like that as well. Another way you can get a coterminal angle, I'm just going to erase this and redraw it because it's busy now. Another way you can get a coterminal angle is to say, all right, well, I'm at negative 120 here. Okay. And I could subtract 360. So that means I'm still going to go in the negative direction. I'm just going to go all the way around. So negative 120 minus 360 is negative 480. And that would also be coterminal. All right. So again, all coterminal means is you end up in the same spot on the Ferris wheel. The reference angle is the angle between the x-axis and the angle that you're working with. It's that angle. It's that sort of symmetric angle. All right. I think that's good for now because this movie is about 12 minutes at this point. I hope the other movies helped and this movie helps in terms of what I'm expecting. And then tomorrow, if you have questions, if you have questions, we will go over them because I know we didn't model a lot of these in class. It was my intention today to do more in class, but we didn't get time for it. So there will be time tomorrow, and I will make a little bit of an extra practice sheet if you guys would like. All right, thanks. Bye.